So I want to talk about how conditional statements in Java is very much, if not mostly identical to the way you learned it last year in C#, but just a little bit more depth on this. I'm just quickly going to go lights off here for a second and show you what I mean by this. Oops. Okay, so statements are executable lines in code that are executed in order in a process that we call sequential execution. That's the way code works, okay? In order to change that, you need to apply what's called a transfer of control. During the 1960s, as programming was starting to develop, a major line of code that was written was what was known as the go-to statement. And believe it or not, this is the genesis of where I learned programming back when I was in middle school. Okay, and I went to a middle school that still exists in St. James called Spring Valley Junior High. It was since sold. It's no longer part of St. James. It's in St. James, but now you may know it as Romeo Dallaire. It's in the Francophone School Division. It's near Heritage Elementary School. Fun fact, that middle school was the last school built in St. James, and it has the largest gym of all schools in St. James, okay? And this is the way the code would look using go-to statements. First of all, in early versions of code, all lines of code were line numbered, right? So you'd put a line like this, 10 print, Mr. Walks is cool. Now remember, this is me in middle school. I did call myself Mr. Walks in middle school, yes I did. And that would be, for example, very similar to a system.out. It would actually just make it pop up on the screen. And then you'd go 20, go to 10, and you'd run your program. And what that would do is it would force line 20 to go back to line 10, which would print out Mr. Walks is cool. Then it would go to line 20, which would then go back to line 10. So what we have here is essentially an infinite loop. That would just keep going and going on forever. And in middle school, that was so much fun to just leave that running on a computer back in the day. So two computer scientists, Bohm, he's got one of those umlauts over the O, so I can't pronounce it properly, and Jacoponi found that in studying computer science, you could write programs without using any go-to statements. They developed a new paradigm in programming called structured programming. They shifted programming in the 1970s to have structure to it. And they found that you could write programs using these three control structures. And they are essentially the stuff you learned last year. Sequence is the simplest form of code, where it runs line by line. Selection, which is where code will branch off into two directions. And repetition, which is to put code in a loop. Sequence in Java involves these three statements: the if statement, the else statement, and the lesser used select statement. And these also appeared in C#. Java has also three repetition statements that we'll go over tomorrow: the while statement, the do while statement, and the for statement. And again, these are the same as they were in C#. So these words, if, else, select, while, do, and for, are reserved words in Java to be used for selection and repetition structures. Okay, so again, just to review, conditional statements control the flow of your program. They will cause sequentially executing code to therefore be branching into different directions. And they are used by executing a Boolean expression test. And again, exactly the same way you did it last year. The expression will test whether or not something is true or false, and it uses relational operators to do this. So a quick review. These are the simple ones, similar to math: less than and greater than. Less than or equal to, which is only written this way, not the other way around. Slightly different than it's written in math. Same with greater than or equal to. And then the two that are probably the most confusing or the most often mistake-driven is the equals sign, which uses a double equals. Okay? And that's important. Single equals is different than double equals. And then not equal, which again uses the exclamation point to indicate not. And again, those might have been easily two that you forgot from last year. but they're easy to mistake. Those are the ones that you're going to find commonly are mistaken. Okay, so real quickly, here's how you write an if statement. It uses round brackets, again, just like C#, and it uses curly brackets, although there's an exception to that. You may recall from last year. We'll get into that in a minute. And it looks basically like this. Grade equals 85. If grade is greater than or equal to 50, print line, you pass, and that's it. Okay, so as I mentioned a couple days ago, the opening brace for an if statement here can be either on the same line or it can be moved down like it was done last year in C#. And honestly, I don't care which way you write the code. You can write it like this, or you can put it on its own line here, but be consistent. Try and do that consistently. Now, who remembers what's the exception where I don't need to put curly brackets? What's the exception? Right, if you only have one line of code inside the if statement, if that's all you need, then you don't need the curly brackets, and if that's the case, you can actually shift this whole line of code up to the same line as the if statement itself, okay? Okay, and by the way, those two curly brackets create a structure that's said to be the scope of that if statement. Okay, now let's add else, just like last year. To add else, we just put else. Now here you see that example without the curly braces. Because if you're using just one line of code, you can omit the curly braces, and as it shows here, if you want, you can shift it actually up to the same line as the if and else. Now again, some programmers don't like code written this way. They think that's bad style. Okay? In my training, in my computer science training, I had professors and bosses who didn't like sometimes when code was written this way. I'm okay with it. I'm okay with you writing code this way as long as you are, again, consistent. To me, in terms of style of code, that's the most important feature, is being consistent in the way you write your code. Okay, so this is the term I was mentioning before, blocks. A block is defined as code that is inside of a structure. That structure usually is defined by curly brackets. So for example, here I have 3 lines of code inside of the if statement. Specifically, if I use the right term, they're inside the block of this if statement. So blocks are usually defined by the curly brackets. Blocks are usually indented to indicate that it's inside of a block. So you can have blocks for if statements. You can have blocks for else statements. You can have blocks for loops that we're going to look at tomorrow. The whole class itself is a block, right? That's what the curly brackets are used to define the class. Who remembers what nesting means in terms of if statements from last year? Go ahead, Daniel. Tell us what nesting is. Oh, wait. Well, the 11 says the answer. What's nesting?
It's having multiples,
I think you're on the right track. What it essentially means is it's a conditional statement inside of another conditional statement. Specifically, again, using the right terms, an if statement inside the block of another if statement. Okay, so if you put one if statement inside the block of another, like for example, right here, then it's nested. Now here again, this looks maybe a bit off the way this code is written, because I've decided to omit the curly brackets. But let's look at the structure here. So this if statement has one line of code. That works. The else statement seems to have one line of code, but that one line is itself an if statement, which has one line, which has an else statement, which has an if statement, which has one line. So the answer is there are no errors in this code. It structurally still works. But here's an example where if you omit the curly braces, it might be incredibly confusing as to where an error might come out. So my advice usually is don't omit the curly braces unless you feel really, really comfortable. And as a matter of fact, I never recommend getting rid of the curly braces. You could probably put them in for all the code you ever write. That's fine. If you want to try and omit them just for saving a little bit of space, be careful about that. Okay, and then from there you can move to the else if statement. And remember, else if is the combination of else and if together. that does have a space between them. But in reality, what it now maybe you should see it as is it's an else statement with the if statement that's just been moved up to the same line. That's really what it is. Okay, so it's just another piece of logic that's incorporating there. But the nice thing about else if statements is they read really nice. Okay, so the else if statements look really nice in the structure in which they're written. So here again, and here I've again omitted the curly braces, but it just reads really nice. And if you wanted to, you could move those all up to the same line if you wanted to. Okay, let's see if you can catch this error. It's not actually a syntax error. So let me just throw the code up there. Okay. Do you see anything wrong with this code? Okay. So here we declare two variables, I equals 25, comma, j equals 50. By the way, I don't think I mentioned that. You can do that. I think I did in grade 10, but you can put a comma and just make multiple declarations on one line. You don't have to do it that way. You can use two lines. Then we have an if statement with braces and an else statement with braces. But does anyone recognize any potential problems in this code? Hang on. Let's see if anyone can catch it. What is it? What do you see? Why not? Okay. Well, that's fine, though. We have an else down here. So you're saying it would always spit this out every single time? That's not really an error. Daniel, what's the error? It's only one equal sign. This is not comparing I to j. This is not checking to see is I equal to j. What this is actually doing is it's assigning I the value of j. So at this point right here, this line is making I into 50 because that's what that's doing. And that's a real easy mistake to always hit, is that forgetting that you need to use a double equal sign right there. Okay? That's simple, but potentially a big problem. And it's such a simple one to miss. Okay? So that's why I put an extra emphasis on it, is I see it so often in coding, is that forgetful thing. Now here's another option that you can use in this conditional statement. It's called the switch statement. I'm not a big fan of this code, to be honest with you. Okay? I don't think, especially as you're learning programming, that the switch statement is intuitive to you. But you may encounter this code, for example, if you go online and look for code. So I'm going to show it to you. I'm not going to hide it from you. So the way the switch statement works is it uses the keyword switch and then the variable that it's checking. So it's switching on day. And then it uses a number of cases. So case 1, case 2, case 3. And this means this is the case where day equals 1. This is the case where day equals 2. That's what it means. This is the case where day equals 3. And if none of those cases apply, it'll go to a default case. This works basically identical to an else if statement. You could have written that whole thing with an else if. You could have said if day equals 1, output Monday, else if day equals 2, else if day, else if, and then finally an else for the default case. Notice it also uses this keyword break that's needed inside a. So the reality is, this is what a switch statement is. I think it's way harder to write than an else if statement. So I don't recommend it unless you're feeling up for a challenge. Go ahead and try it. But you may encounter this code online and be wondering, what the heck is this? It's just essentially an else if statement. That's what it is. Okay. Whoa. And that is it for the presentation. Let's try this now within our example. Okay, so let's do an example of an if statement. And for this example, let's also try and incorporate random numbers, which is something that I think you might want to use. So I'm going to try and use random numbers for this example. Okay, here's how random numbers work. Let me just make some space here. Random numbers start with math.random. But what math.random gives you, I don't know if you can see on the projector right now, but it gives you a double value. Okay? So what math.random gives you is a double that's in between 0 and 1, but it never actually reaches 0, and it never actually reaches 1. So it's a decimal number. So again, for example, it would be something like from 0.5 all the way up to 0.999999999, and something over on this side like 0.0000001. It'll be some random number in that range. Okay, but that's not necessarily useful to you. Like, let's say again you were incorporating something like a card game and you wanted a random number between 1 and 52. Well, that random number doesn't help at all. 1 second, everybody. Okay, so in order to actually make random numbers within a range, there's a formula for doing this. Now, there is actually a similar way to do it in C, like we did in C#. You may recall last year we did that thing, random equals new random. But I wanted to teach you the random number formula because in reality that's what you might want to use in other programming languages. It's a little more generic. So here's the way it works. You start with a high number and a low number. So let's make a random number between 1 and 100. That's a good start. So I'm going to start them off as constants. So final int high equals 100. That's my high number. Final int low equals 1. So it's that'll be the range between that high number and that low number, okay? And we're going to use integers. We're going to use whole numbers, not decimal numbers. The problem is that it starts off as a double. So I have to start as a double. And usually that random number that's in that range is called the seed value. So I'm going to call it seed equals math.random. So that's going to seed my random number calculation here. What I now need to do is incorporate that into a formula to come up with a random number. Now you may know from your algebraic training that in math that you can take formulas and then simplify them. But I'm going to make this a long version of the formula to start, and then I'll show you the simplified version. So what I'm going to do is I'm going to turn that high number into a double, and I'm just going to call it h equals. Now who remembers how I can do that? How can I turn an integer into a double? We learned that a couple days ago. Casting, exactly. So I do this, double high. So now h is 100.0. And I'm going to do the exact same thing with the low. Double L equals, I cast it like that. Okay? And again, normally you wouldn't go through this whole process, but I wanted to show this as an example. So now I have a seed, which is a double. I have a high number and a low number. What I can now calculate is my random. And this is the formula. High minus low plus 1, you have to add 1 to it, it's part of the formula, times the seed value plus the low value. So that is actually what's known as the random number formula. High minus low plus 1 times the seed plus the low. What that will generate is a random number between 100 and 1. However, it's still a double at this point, and I want to turn it into an integer. So my final value, my number, wait, do we already have number? Did we already create that one? We did. So let's use a different name. Integer choice. Oh, I think we have choice too. Let's call it card equals, and here I do a cast again. Now I cast it back as an integer. So I've casted it finally back into that value. Now before we do the if statement, let's test that. Let's output what card is. So what we should get is a random number between 1 and 100 as an integer. So I'm going to run that code. And because we had the code in there from yesterday, it's probably going to run all that stuff as well. So it's going to bring up those displays, welcome to the pet shop, etc., enter age. That's all still coming up from yesterday. But here you can see at the very bottom, it's giving me that random card value. And again, all I would do is change this. So if I want to make this an actual card game, I could make that between 1 and 52. If, let's say, this was going to be a dice game, I could make it between 1 and 6. If this was, say, rock, paper, scissors, I can make it between 1 and 3, and it would give me that random number between the values that I set. Now, I don't want you to key this in, but I'm going to show you how you could use your math skills to simplify this formula. Okay? So I'm just going to take all this code and comment it out for a sec and repaste it in. And then now I think to myself, okay, this is random right here. And random is the same as this. So in other words, I could put this in place of that, and I don't need that line of code, right? Because this line here means the same as what it did before. Similarly, this means the same as L, so I could put that in place of L there, and it would work the same. I wouldn't need that. And I could take this in place of high. I could place it there. And I wouldn't need those lines. And in reality, I could also use this in place of seed right here. And I wouldn't need that. And really then I could just turn that whole code into one line like that. But the question is that an easier line to understand than what we had before? And in reality, I don't even need high and low. I could have just punched the numbers right into there. I could have just put 100 there. Oops. And I could put 1 right there. And it would still essentially work the same way. But that line of code, let me just zoom back so you can see it, is not necessarily that easy to understand, because although you can use your math and algebraic skills to sort of create formulas like that, there's a higher chance of possibility of error, and it's less likely that that code will be useful to you in the future, which is why I wanted to take the time today to sort of break it down more like that. Okay? So that's the case now. Okay, so now that we have this card value, let's use an if statement to test it. So if card is less than or equal to 50, or sorry, less than 50, let's say less than 50, let's output you fail. Okay? So we'll use this like as if it's marks. Else, S out, you pass. With, and let's put the card there. So here you can see the if statement in action. It basically checks that number, and if it's less than 50, it'll output you fail. And for anything else, it'll output you pass. Okay? So this gives the possibility of those two scenarios. So if it generates a number like 65, 65 is not less than 50, so it'll drop to the else statement and run that code. If it's any number less than 50, it'll output you fail. Quick question. How many numbers generate a pass and how many numbers would generate a fail, statistically? How many numbers would generate pass? Come on, you guys can do the math on that. Well, what numbers are not less than 50? No, 49 is less than 50, Cyrus. What numbers are not less than 50? 51, all the way up to 100, but there's also one more. 50 is not less than 50, right? 50 is equal to 50. So 50 all the way to 100 would be the numbers that would go down to here. Numbers that would be in this zone would be 1 to 49. Okay? All right, so let's expand on this. Let's slip something in the middle. Else if card equals 50. Okay? So here's the else if in action. So with the else if, we now have 3 scenarios. And let's output, you got 50. Okay? So remember, what happens with the code is it comes down to here. And let's say the card at this point had generated a 75. Okay? So it comes down to the first if statement. Is 75 less than 50? No. So it drops to the else if. Is 75 equal to 50? No. So it drops again. And when it gets to the else, there's no check right there. It doesn't say anything. So it will execute this line right here. That line will execute because that's the else. That's the like, for anything else, run this line of code and it'll spit out that 75 when it does that. Okay? So now let's try another scenario. Let's say this time card is 40. So it comes down to the if statement. Is 40 less than 50? Yes, it is. So it executes this line of code. And in an if statement, when it executes this line of code, when this has executed, these two do not execute. So once it's finished this line, it goes past the rest of the if statement. Remember, that's how the if statement works. I explained that in more detail last year in grade 10, but that's the example of how you can incorporate if statements into your code.